Hello to you guys. A very warm welcome to all of you. Thank you very much for taking the time to be part of this show. My name is Sibusiso and I'm coming to you live from our Johannesburg studio to bring you another epic episode of your favorite show. This is Tenfold Live, which comes to you every weekday, Monday to Thursday from 5 p.m. until 6 p.m. Remember, this show is proudly made possible by Liberty, and you can be part of it by just hitting us up on social media, be it on WhatsApp or even on our Facebook page. If you want to ignite your passion in mathematics and fancy distinction, we encourage you to download our Tenfold Education app, which is available on your app store, be it iOS or the Google Play Store. Just go there and download it. It will help you build your content from grade 10, grade 11 up to grade 12 as you prepare yourself for your end of the year exams or your June exams, even your preliminary exams. Remember, this week we are starting a new topic. This is analytical geometry. We are done with calculus, so we're actually right at the end before we do our end of term revision as we prepare you guys for the exams. So we are doing analytical geometry today, and we've got a jam-packed show for you today. We're giving away awesome prizes. We've got awesome intro video that gives you access to great information regarding analytical geometry. We've got lots of questions from you guys, so do stay tuned for all of that. Everything else is coming your way right now, so do make sure you don't miss that out. Speaking of the concept video, we're now going to go and check out a concept video that will help us orientate ourselves to analytical geometry so that we can actually make sense of what exactly is analytical geometry and why we need to take it serious. So do stay tuned. We'll be back after this intro video.
Analytical geometry, also referred to as Cartesian or coordinate geometry. Analytical geometry uses algebraic methods to represent and solve geometry problems. The correspondence between geometric shapes and algebraic equations means we can convert geometric problems into equivalent algebraic problems and solve using algebraic methods. To be successful at analytical geometry, you will need to understand all of the work done up to grade 11 and, in addition, the concepts of equations of circles, equation of a tangent to a circle, and length of a tangent to a circle. In preparation for your exams, make sure to watch all of the analytical geometry videos and attempt all of the assessment equations at the end of the lessons. Once you have mastered those skills, the career video will take you beyond the classroom. Analytical geometry is roughly 40 plus minus 3 marks in the final exam, which is approximately 27% of Maths Paper 2.
Right, 27% guys, 27% is a lot. Like, there are 4 topics in paper 2, stats, analytical, trigonometry, as well as Euclidean geometry. I won't lie to you, I know you guys struggle a lot with trig as well as Euclidean, so I would like to advise you to do a lot of work on these easy topics that you know will help build your confidence and help you to prepare and get good marks. The stats part as well as the analytical are easy ones that you always have to make sure that you ace them. Once you ace those ones, you can actually be able to start fighting with your trig and your Euclidean geometry. So looking at this video, it helped me to actually see something very important here. Analytical geometry's got a lot of concepts that come from grade 11. Like I said, if you want access to the video just so now, or you also want to build your grade 11 concept, make sure that you download our Tenfold Education app. It will help you build yourself before you start working with grade 12 analytical geometry, because this show is specifically for grade 12 content, but if you're in grade 11, you can still also benefit a lot from the things that we do here. We will move on. Like I said, I was not bluffing earlier on when I said you guys have stand a chance to win awesome prizes by sending us your questions. So if you want to win something nice, just send us a video of any question you want to ask around our concept of interest. Like this week, we're focusing on analytical geometry. So if you have a question, take yourself a video where we get to see you and we get to see the question long enough, then you actually can win yourself awesome prizes. One person who has done exactly that is Sia Pila. Sia Pila won themselves an awesome 19-inch TV. If you want to be like Sia Pila, just make sure that you send us a video. Who knows, maybe it's going to be you who wins something. So we're going to go and check Sia Pila's question and then help Sia Pila with this question to try and help you also, if you're watching the show, so that you can see how do you actually approach analytical geometry.
Hi, my name is Siapila Tusini. I need help with this sum.
Congratulations, Sia. We will actually make sure we are in contact with you to give you your awesome prize. 19-inch TV, I would love to have that. Anyways, this is a nice question that I want you to take a look at first, because sometimes you don't get to see the videos that the other learners are sending on the show. So I want us to take a look at the screen here so that we can be able to read the question together before we even try to analyze this question. It says to us that we need to prove that the radius of the circle having the equation x squared plus y squared plus 4x cos theta plus 8y sine of theta plus 3 equals to 0 can never exceed the square root of 13 for any value of theta. All right, so that's basically what we need to do. A circle can have any radius. It can have any radius. So this question is asking us to show that whatever the radius that we can have for any value of the angle theta, that radius can never exceed the square root of 13. Now, this is what I call complex questions. A complex question integrates two concepts of math. This one integrates trigonometry as well as analytical geometry. We want to see how do these two merge together to try and help you to figure out this question. Now, let's see what is happening here. It says to us that we have to show that the radius can never exceed the square root of 13 for any value of theta. Now, if I try to make sense of this, remember a circle looks like that. And the radius of the circle can be anything. So we want to see, can we be able to show that the radius will never be any number that is greater than the square root of 13. We want r to be less or equals to the square root of 13 for whatever the value of theta that you could be working with. Now, the most important thing you need to do when you're working with these things is to consider the given information and then consider what we call the magic part in this question. The magic part is the actual concept that is involved in that particular question. So I don't know much as I'm looking at this question, but all I know is whenever I'm given the equation of the circle, which in this case is x squared plus y squared plus 4x cos of theta plus 8y sine of theta, right, plus 3 equals to 0. What can I do with this? What is the best thing that I can do on this question? Let me just shift this so that we have enough space here for us to make sense of this. The magic part is the concept, the actual concept that is involved in this question. Well, what I know is if I can change the equation that is given here into the form x minus a squared plus y minus b squared equals to r squared, then I can be able to focus on the radius and then start answering the question. So what you're looking at here, Siapila, is the idea around finding the radius. If you can find the radius on its own, and then you can be able to do further analysis on that. Until we can be able to find ourselves there, there's not much that we can do on this question. So now let's go and try to change this question. How do you actually change the equation of a circle from the given format to the required format? We want to go from the given and transfer it to look like the standard equation of a circle centered at any point of interest. Now, for me to do this, I need to apply a very nice concept which is called completing the square, which a lot of people don't really like. So what do you do when you're completing the square? You firstly make sure that you group the x's together. So I'm actually going to say, okay, let me write my x squared here, and I'm going to take this term, which is 4x cos theta, write it next to the first term of x squared. So I've got 4x cos of theta, right, plus, and I'm going to put the y's together. I'm now sitting with y squared plus 8y sine of theta, which I'm now going to separate from 3 by taking 3 to the other side. So when you're completing the square, what you're simply doing when you're completing the square, you just take half of the middle term. When you've got x squared and the x term, you take half of the coefficient of that x, which will then become something, and then you're squaring it. Remember, we are completing the square. So you will add on both sides of the equation half of the middle term squared. Right, so let's see what is going on here. So according to this, if I just fix it quite nicer for you, I will write this as 4 cosine of theta multiplied by x. Let me just put the x on the side here so you guys can see what is going on. I also have y squared plus, I want to put 8 sine theta side by side and put y there equals -3. Let's simplify further and see what will happen. Well, we want half of this. You just want half of this squared. So we're simply going to sit with x squared plus 4 cos of theta. Completing the square requires us to add. What are we adding? We're adding half of 4. Half of 4 is 2. So we're adding 2 cos of theta. Remember to square it. Right, and then after that, we are going to do the same thing for the y's. So I've got y squared, I've got 8 sine theta multiplied by y. Again, I'm going to add half of that term, which is actually half of what? Half of 8, which is going to give us 4 sine of theta. Don't forget to square this. But this is mathematics. Whatever you do on the left-hand side, we need to remember to do the same thing again on the right-hand side. So we added again here 2 cos of theta squared, and we also added 4 sine of theta squared. We just had to do this so that we balance our equation. Okay, fine. Now, simplifying further, this is actually a very nice way of finishing it off. Your teachers might tell you, well, you need to work out what is 2 squared, which is going to be 4 cos squared theta, and then try to factorize this. I just simply say this. When you're completing a square, you take a square and a square, you make a square. That's as easy as it is. Completing a square, take a square and a square, and then you make a square from that. So what we are going to do is I'm going to take a term from this x squared and take a term from the 2 cos theta squared, and make my square there as I'm completing a square. So it's simply going to become x, and I'm going to take this one there, which is plus 2 cos of theta. You take a square and a square, you make a square. Done. Do the same thing again for the y's. I take a square from the y's and a square term. It's going to be y plus 4 sine of theta squared. Right, it's going to be equal to what? Now, when you simplify what you have on the right-hand side, you will basically have minus 3. This is 4 cos squared theta, so it's going to be plus 4 cos of squared theta, and lastly, that is 16. So 16 sine squared theta will be what we're getting from 4 sine theta squared. Very important stuff happening there. All right, now what we're sitting with here is the equation of the second in standard form. If you look at it quite easily, x, the a term is that, y, and then the b term is this. Our r squared is what you see on the right hand side. That is our radius. So now we need to analyze what is given there. Since your radius squared is basically minus 3 plus 4 cos squared theta plus 16 sine squared theta. We need to show that whatever you're sitting with as r squared can never exceed the square root of 13. Now, to be honest with you, analytical geometry is done. The analytical part of converting the circle to the standard form in the form of the center and the radius, that part is done. What is remaining now is your knowledge of trigonometry. And this emerges a lot when you're doing mathematics, particularly in paper 2. There isn't a lot of things they can ask you when they're asking you about analytical geometry. So they keep dragging from Euclidean geometry and your trigonometry. So do expect that these kinds of things can happen. We now need to show what we are sitting with here can actually never be greater than the square root of 13. So let's check it quite further. When I see this, I actually see that we've got cos and sine. And I think we need to simplify it much more by changing one of them to look like the other. Right, so now I'm going to use the squares identity. This is from the squares identity. I think you guys know that sine squared theta plus cos squared theta is basically equal to 1. I'm trying to express everything in terms of one ratio as opposed to so many ratios. So I'll keep my form, but my cos squared, I'm going to change it to 1 minus sine squared of theta, right, which can then be added to 16 sine squared theta. If you simplify this further, you will have minus 3. If you multiply in here, you're sitting with 4. 4 times this is going to give you minus 4 sine squared theta plus 16 sine squared theta, which when you clean it up further, minus 3 plus 4 is going to give you positive 1. 16 sine squared minus 4 will give you 12 sine squared theta. This is the value of your radius squared. Now, the only way of analyzing trig expressions and equations in a much easier way to show whenever something is not going to exceed a particular value is by trying to think of them graphically. Imagine a sine graph. I don't know if you have an image of the mother graph of a sine graph in your mind. Let's see how we can use that to try and complete our question and show that it will never be over the square root of 13. So what I'm sitting with here, I'm sitting with 1 plus 12 times something squared. Now, what you're sitting with here inside the bracket is basically sine theta, which when you draw, it's going to be a sine graph that looks exactly like this, the mother graph of a sine graph. Now, the ever possible highest value you can get for any value of theta, remember theta is on the x-axis and y is along the y-axis as usual, is that for the graph of y equals to sine theta, just the graph of sine theta here, will peak when y will be 1 when the angle we're dealing with there is 90 degrees. So the highest possible value, the highest, before 90 degrees, the 30 is half. Before 30, the value is even lesser. So as you increase the angle, the graph value grows and grows and grows until it gets to the highest possible value. And the highest possible value in this case is going to be a 1 when theta becomes 90 degrees. After 90, the values start to drop again because the graph is going down. So according to this graph, it will never go beyond the value 1. So that is the highest possible y value you can get on the graph of sine theta. So I'm going to take that 1 and substitute it on this equation. I'm going to say the possible maximum value that you can have here. And look at me changing my r again. I'm going to say r squared max, the highest possible. When theta is anything else, our radius is going to be smaller than what we are going to get now by using a 1. So I'm going to simplify this and say, okay, fine. It's going to be 12 times 1 squared. 1 squared is 1, 12 times what you're looking at here. So r max squared is 13. So the highest radius you can get here is basically the square root of 13 when you try to put the square root on both sides. It's a very interesting question that requires you to use your knowledge of your trigonometry knowledge in terms of graphs to see when will a graph be the highest possible value. A very nice question indeed. Thank you very much for that, CIP, and congratulations for your prize. We will come back again with more great content. Do stay tuned. Don't go anywhere. We've got a lot of interesting things that are coming your way. Stay with us.